It's still saying it's booted up. So once you see down in that corner where it says live video is starting.
Oh yeah, it says end stream. Or wait, move that way a little bit, Lily.
Oh, there. It's weird how it's different screens. Okay.
Should be good. And then, okay, now you.
Okay. Hi everybody, and welcome to today's Facebook Live. My name is Lily, in case you haven't met me yet, and I am one of the AmeriCorps here at West Valley Outdoor Learning Center. And today we are going to talk all about snow and the science behind snow. So I'm going to wait just a minute for anyone to join us if they would like to join us. And thank you all for joining us for today. So I'm going to let those people come and join us, and I'll get back in just a minute.
It says it is on one.
Oh, it is.
I can't see it.
Okay, so I think I'm going to go ahead and get started today. Thank you guys for joining us. If you want to write who you are that are joining us in the comment section, Davis is here with me today. He is our other AmeriCorps, and he's going to let me know when I can do a little shout out and say hi to you guys. So, like I said, we're going to do our live all about snow, and there we go. First, I want to talk about what makes snow snow. So first, we need to understand how it's made. So if anyone can write in the comments section, what are the two things that we need in order to make snow? I'm going to give everyone, it's a very simple question, so I'm not trying to trick you guys. Go ahead and write in the comments section. I'll give you guys like maybe a couple seconds, 30 seconds to do that. And then we'll get going more. Learn more about snow. I hope everyone's having a great week. All right, I think we've got someone. Water and air, right? So yes, water is very important. The other thing though is cold weather. It needs to be cold in order for there to be snow. So water, we got one, and the other one, like I said, is cold. So the other thing that makes snow, I'm sorry, I need to rewind a little bit. Water and snow are what we need, obviously. So in about 20 inches of snow, there's only 0.1 to 4 inches of water. So there's really not that much water that's in snow. It's mostly made up of air and this cold weather. Also, it has to be colder than at least 41 degrees Fahrenheit in order for snow to start falling. Commonly we see snow sticking around those temperatures, even a little colder. But now I want to talk about the characteristics of snow. So really what makes snow snow. So if you think of anything that makes snow snow, I want you to put it in the comments section. Like what do you think of when you hear the word snow? What reminds you of snow? I want to know. Some background knowledge about me is that I actually did not grow up in snow. I grew up in Las Vegas. So I didn't have a white winter, I didn't grow up in snow, and I was surprised when doing the research for this that snow can be a lot of different colors. So the colors that come from snow are actually due to a lot of different things. So things like yellow snow, I'll go over this image over that way. And yellow snow, everyone knows what causes yellow snow. But orange snow can happen when there's dust around, which I thought was cool. Red snow, which I think is the absolute craziest kind of snow, happens when there's things like dust or algae or these little tiny things called cyanobacteria. When those mix with the snow, it can turn red. Gray snow, I think a lot of people know it can come from soot and things like from fires or stuff like that. Snow can look blue, which is my favorite color, when there are shadows on the snow. So a lot of times when you see blue snow, that's because of the shadows. And snow can turn green too because of algae and things, the same things as makes it turn red, the cyanobacteria. So there is one thing though that could make any of these colors, the snow turn any of these colors, and that's pollution. So if you're able to, I think you can read actually the snow, what causes colored snow. And you'll see that pollution is in every single one of those. So pollution makes snow turn all of these different colors because they mix with the water. There is this picture right here is actually in Antarctica. It's called Blood Falls, and it's not pollution. This is actually caused by iron oxide in the salt water. So iron will make things turn red. So that's why this ice and snow is actually so bright red. So as the snow and the ice kind of melts, it looks more and more like blood and like red. So that's why it's called Blood Falls. And this is a great example of how things actually, the snow can change colors. Snow is snow too because every piece of snow is made of ice crystals. So now we're going to talk a little more about crystals, which I can crystals. So there's a lot of different kinds of ice crystals that can form. Every single snow flake is unique, which is really cool. And the type of ice crystals that form though change depending on the weather conditions. And this chart right above me shows that as humidity increases, so this is over here, as it increases, humidity or supersaturation increases, that means that there's more water in the air. And then as the temperature decreases, then certain crystals are going to be formed, and that changes depending on those conditions, which is really cool. And there are two main types of these little tiny snow crystals. There's plates and there's columns, and then they can make all of these different kind of shapes with those two things. Crazy. Fun science fact and word. So fractals are really cool. This is kind of away from snow so much, but fractals are really complex patterns that are similar no matter how big or small they get. So you can see in this GIF over here of the triangles, no matter how big or small these triangles get, that pattern stays the same. So snowflakes are actually fractals, and no matter how big or small they go, you're going to be seeing those same types of patterns as you zoom in, like in a microscope, or you zoom out, which is really cool. Looking at the bigger picture, even though snow is made up of all those ice crystals, there are several different types of snow. And this is because, like I was saying, the temperature and humidity levels will change when the snow is falling, and that changes how the snow and those crystals are actually formed and come together. So there are four main types of snow that fall. We have singular crystals, which are these guys over here that we've been looking at so far. And that's just one single crystal of ice that's making up the snow. Next it's called hoarfrost. Hoarfrost happens when moisture is going from a vapor to a solid. And this has a lot of ice crystals that are like locked together and stick together. And they'll stick onto things that are surrounded by air. So things like That's going to be right above us, that picture. These are things like wires, fences, tree branches, leaves. That's what hoarfrost is sticking to. Grapple, which I'm hoping I pronounced right, is just right here next to me. And grapple is small rounded snow crystals. So hail and sleet and obviously grapple are all within that realm of small crystals like that. And how these are formed is when ice crystals are going to be falling through really, really cold clouds. These clouds, though, are still liquid. But even though they're liquid, they're technically below freezing temperature, which is another crazy cool phenomenon that happens in science and meteorology. But as the snowflakes are falling through these like super cold clouds, they attach to these cloud droplets, and that's what makes them form into these pellet-type shapes. And it's crazy cool science. The last type is a polycrystal, so that's this guy right here. A polycrystal, you can kind of figure out what this word means by just breaking it down. So poly means many, and then crystal, we know what crystals are. So it means many crystals. A polycrystal is going to be a snowflake that's made of many different ice crystals. So you're going to have these like singular ice crystals all clumped together, and that makes a polycrystal. So now that I've covered all these types of crystals, let's talk about the actual types of snow. So a lot of you guys have probably heard of these types of snow before, but I wanted to go through them and talk a little bit more about them and kind of how they actually are formed, because I think it's pretty cool. So powder is the first type of snow that I'm going to talk about. This happens when the temperatures are really low. So I'm talking like 18 to 28 degrees Fahrenheit, which is very cold. Powder is going to be really light and dry, and it's easily cleared away. So this is, a lot of people love powder snow, and that's this one right there. So the next kind of snow is called fluffy snow. That happens when it's a little bit warmer, around 25 to 30 degrees. After that, so that's going to be this guy. After that is wind-packed snow, which is the one over here. Let's do it this way. Wind-packed snow can fall at a lot of different temperatures. So it can fall when it's really cold, it can fall when it's warmer. And this is the kind of snow that is, the wind ends up packing it together a lot, and it's used a lot for igloos, which is really cool. It's also the type of snow that ends up in avalanches a lot, which is a fun fact. And the last type of snow is actually wet snow, which is a picture all the way down there. Wet snow or slush, and I think a lot of people know this. This is not my favorite type of snow, but it's full of moisture. This is going to be snow that's really, really wet and heavy. It's the warmest, it's the snow that falls in the warmest temperature, so around 30 to 35 degrees Fahrenheit. And this is the type of snow that you can see causing really big problems and safety concerns. And it's the kind of snowfall you see when you get the day off school. So you can see in that picture up in this corner that the different types of snow can actually affect, they're heavier than others. So this really wet snow is actually equivalent to, I think it's 3 trucks worth of weight on your house if you have that much snow on it. Really light snow is like 1 little car worth of snow. So that's why we see so many issues when it comes to heavy snow, is because it's just heavy. It can break things. Wet snow is also full of water, and water is heavy. Okay, so next I want to talk more about dangers of snow, specifically avalanches, because we're talking about snow, and heavy snowfall. So I want to show you guys some pictures of what happens when an avalanche comes through an area. So the picture over here is actually from Seattle area. So you can see the before and after from when a avalanche came through. And you can see in some of these, I think the one right above me, and this one that I'm kind of walking as well, avalanches can cause a lot of destruction, but that's actually not necessarily a bad thing when it comes to nature destroying itself. It's actually a good thing. So avalanches can be both beneficial and detrimental to the environment, and this is because these avalanches help to clear trees. You can see it really clearly in like the picture above me. And as these avalanches clear the trees, they're actually clearing them because a lot of the trees are too dense. So that means that there's too many trees packed against each other. And the avalanches come through, they clear it, and it can help to create a natural fire block. So these areas are separated now, so when fires come through, it's less likely that you're going to have the whole forest catching fire. You might be able to have it stop in this little section here. Next is my favorite part, the plants and animals that live in the snow. So snow is super helpful for both plants and animals, and a lot of animals actually change their coats in order to blend in with the snow. Other animals hibernate, so we have a little pika up here, and I believe that they hibernate. Now that I'm thinking about it, they do. I just got confirmation. Pikas do hibernate, as well as like marmots. Marmots around here will actually hibernate from like October until April or May. So that's a really, really long time. And it's really, really cool as well because they're able to kind of shut down their internal organs and survive through these really cold winter months. So that's something that very few animals can actually do. And I mean, humans, we can't do that. I think it's super neat. In terms of fauna, so it's going to be the plants and things that are growing. Plants like conifers or pine trees, like above me, are made to be able to handle the snow. So we know that a lot of the deciduous trees are the ones that are going to be losing all of their leaves, right? The pine trees are around when it's getting really heavy snow, and they're shaped like this cone shape, and that cone helps all of the snow to fall off rather than being stuck there. Oh, I was just told pikas do not hibernate, but I know marmots do. So marmots definitely hibernate. I am very sorry for the misinformation about pikas. Anyway, back to plants. So the best trees were the ones that look like cones for the snow. And that also helps because snow, like we were talking about, can get really heavy. And that snow, if it gets too heavy on the trees, is going to end up breaking and killing the tree. So by shaping itself like a cone, snow just falls right off. That's a lot of the times, I shouldn't say a lot, that is why our houses also have kind of this cone shape at the top, so snow can fall off of the sides, as well as other things like rain, but snow is definitely the heaviest. So snow is beneficial though to more than just these pine trees, even though that's all I've talked about. When snow starts to melt, the ground is really wet and is perfect for things like young plants when they're growing. It makes it super, well, wet and healthy, and it's all of these in the spring. That's why we see so many plants growing, because of that. So next I want to talk about something that's in the midst of changing, which is climate change. So temperatures on Earth are changing. This is not something that is debated. We have proof, and I have proof on this slide as well. And you can, all of these charts and maps that I have on this slide show you how much snow is actually in the United States. So the one right above me is, can't quite read the dates, but I think it's to about 2019 or 18. And you can see that, 2016, sorry, and you can see that it is declining. So all the way down, it's declining. So we're seeing less and less snow as we get closer to the present. Let me see which way I should go for this one. This way. Okay, so this guy right here is all about if there is more rain or snowfall. I think I messed up here.
You froze.
No. Okay, so the map here, you can see that a lot of places are seeing more rain than they've ever experienced before. So all of these green spots, the green states, are seeing more rain. If it's blue, they're seeing more snow. So all of these, you can see Washington is one of them up here. They're all seeing more rain than they've seen in the past. And then finally, I'm going to explain this guy over here, which I think is the coolest image that I found. This shows how much snow has changed from 1949 to 2020. So this is very, very recent. Scientists took measurements of snowfall across all of these years, and they made a map showing what areas are seeing less or more snowfall. So the reddish-orange places, all those circles, are areas that are seeing less snow. The blue, which you can see there's not that many, but the blue circles are getting more snow than they used to. So you can see that most places are getting less snow than normal, including up in Washington. So up here in Spokane, I can't actually point to it, I wish I could, but way up in the corner, you can see that we're getting about 20 to 30% less snow than we have in the past. And this is evidence that the temperature on Earth is changing. If it wasn't changing, we should be seeing similar data and similar amounts of snow than we were in the past as well. And that's not the case. More evidence of the weather changing is coming from glaciers. So up here in Washington, we do have glaciers here. So you can see up in the very corner picture, those are the areas where we have glaciers in Washington. They're not really by Spokane, but it's still Washington, which is cool. While glaciers aren't technically snow, they're like really big chunks of ice. There's still snow on them, so I'm counting them. And some of the glaciers that are melting now actually have never been liquid, and it's crazy to think that these glaciers that have been ice, like basically since the Earth was formed, are now turning to liquid water. It's mind-blowing. So you can see in all of these before and after pictures that there was a lot of snow and ice on these glaciers, and now there's much less, if any, snow and ice. So we have our picture here and our picture up here, our before and our after, before and after. And some of these have like barely any snow at all. And this is because the temperatures on Earth are warming and we're not seeing as much snowfall as normal. Okay, so ways that you can kind of help stop climate change and these warming temperatures are very simple things, and I'm sure you've heard of them before. And so we're talking about things like saving energy at home, turning off lights, turning off water if you're not using it. Very small, simple things that you can do. There are some larger things you can do as well, or more your parents can do, adults can do, which is switching your energy source. So using renewable energy like solar panels or wind power, that can all help to end this climate change because you're using less energy. And the energy is kind of what's, you're not using less, you're using less non-renewable resources, which is what's causing all this heat and the climate change that we're seeing. Other things like switching to electric vehicles, walking, biking, taking public transportation, that's all in the same realm as changing your house and what you're using. Another thing you can do is, why I have the veggies on the slide here, is to eat more veggies. So vegetables are actually, they take a lot less energy, land, and water to make than, say, meat does. Now, producing these plants results in fewer greenhouse gas emissions. These greenhouse gases are what's really creating the warmth that we're seeing and why all this ice is melting, or snow is melting, and why we see these big drastic changes in temperature over just a couple decades. In addition to eating more vegetables as opposed to meat, we want to see people recycling, reuse, reduce, recycle. We've all heard the 3 R's. And composting. Instead of throwing away your food, if you compost, you are helping the environment. You're making sure that less goes into our dumps and our landfills, which is really beneficial. Yay. So that's all I've got on snow. I just want to say quick, do a little shout out. If you're not following us on Twitter already, please follow us on Twitter. That's our Twitter. If you're not following us on YouTube, please follow us on YouTube. Oh, not Twitter. I'm so sorry. I don't know what I'm thinking today. Instagram. Thank you. Instagram. If you haven't seen us on YouTube yet, please check us out. All of our Facebook Lives go on there. We also have some fun little crafts for people to do if you would like. So please check out our YouTube channel. And then hopefully, since this is on Facebook, you guys are following us on Facebook. But if you're not, go and check out our Facebook just at West Valley Outdoor Learning Center. If you are watching this on the replay, please feel free to ask any questions or make any comments you have about snow, and I will answer them back as soon as I can. Otherwise, I hope you guys have a great winter break, and I can't wait to see you guys back in January. Bye!
Did it go? Oh, it disappeared?